Okay, guys, welcome back in our lecture number 7. Okay, last time we finished. Which phase we finished last time? Still, we are in the analyze phase. We are talking about the 7 tools of quality. From the 7 tool of quality, we spoke about only one, which is the fishbone diagram, and we saw it in the Excel sheet. So today we will discuss, and this is the how it looks like, and we saw how it's being built. So today we have number 2. We said we have 7 tools of quality. We have 7. Yeah, yesterday we spoke about the fishbone diagram. So today we will talk about scatter plot. So what is a scatter plot? Scatter plot is a graphical tool, same like a fishbone diagram. Okay, so fishbone diagram you will design it yourself in the Excel, or using in the green you will use the mini tab. There is a mini tab, especially for Six Sigma. You will use it in order to draw or to build the fishbone diagram. Scatter plot, it's in the Excel. In the Excel itself, there is a scatter plot. We will see it right now. And also in the mini tab, there is scatter plot. So what it tells us is scatter plot. A scatter plot tells us about the relation between two variables. So this too is very important tool that will help us estimating the degree of the direction of the correlation between two variables. So there is a two variables using the scatter plot. So scatter plot will help us to know the correlation between those two variables. So if we have these two variables, they are moving in the same direction, what you call it full positive correlation. They are moving in the same direction. Okay, there is a full negative correlation. They are moving in opposite direction. You have this is two options. Or we have absent of correlation. There is no any relation between the x and y. Or there is a limited degree of correlation. So there is, we can see here, there is a type of this is four we spoke about. There is a positive correlation. The data is from the left to the right with this shape. So when you see it, immediately you realize this is a positive correlation. And the data variation is small, point. But if it is in the same direction, and there is too many variation, this is, we call it positive correlation. Here is strong, and here is only positive. So there is no strong here. So this is only the difference. When you see it with this shape, that means a strong positive correlation. When you see it with this shape, the data itself, that means only positive correlation. Negative should be the opposite of that. So the data, it will move from the left, from the right to the left. Okay, from the right to the left, and there is no too much variation. It is only small variation. So we call it a strong negative correlation. In the same way, from right to the left, but there is many variations, so we call it negative correlation. There is no correlation with this one, the data in the middle. here and here and here. So there is no any correlation between the X and Y. This is other type of the scatter plot. So let us see it in the Excel. So this is, we will take a sample of scatter plot. We have, this is a temperature, and we have the sales for jacket. So once the temperature increase, the sales of the jacket will be reduced. When the temperature reduce, the sales of the jacket will be increased. So this is what we call it. This is a positive correlation or negative correlation, because they are moving in the different direction. So here is the question in the exam. This is always it will come. The scatter plot, we are using scatter plot for forecasting. Yes, you have to be careful with this one. Scatter plot, the main thing we do it in the scatter plot forecasting. This is, it will come definitely in the exam. So the scatter plot, always we are using scatter plot in order to have the forecasting for the sales. So for example, we have when the temperature is 40 degrees, we didn't sell anything on the jacket. When it was 38, we sell 2 pieces, and so on. When it was 5, we sell 73. So you can from here, you can forecasting when it is -6 or -7 or -10, how much you will sell. So this is what we mean by forecasting. If we draw down, it will give you -18, you will sell 60. Okay, -14, you will sell 55. So this is, it will give you indicator of or forecasting about your sales when you are using the scatter plot. The scatter plot, this is a design for the scatter plot. This is from where it's coming. This you need to highlight your table. Okay, insert. You go to recommended. There is a scatter plot here. You can use it from here, or there is another one here. You can select whatever you need. There is a many type of scatter plot. Just click, so it will be the same. This is the scatter plot. The main thing we need to come out from this scatter plot, if scatter plot has been used for forecasting in the sales. This is a scatter plot. Okay, guys. Secondly, or third, number 3, we have flow chart. Flow chart, I think we discussed before. Flow chart is basically it's a process map. So it's the same. The process map, the flow chart, it's the same thing. We have one thing, but it has two names. So flow chart are I think we discussed it in the lecture number 2 or 3, and we saw how to make the flow chart or process map, and even how to develop the process map, to use it from one shape to another shape after you make brainstorming, after you make for example gathering the team and working on the process flow or process map. They will come up with a different than you're thinking. So when you take it and make or remove the non-value added, it will give you another shape of the process map. When you put it in the computer, or we said computerized, then it will give you another shape of the process map. So basically, process map is a flow chart, and the flow chart is a process map. So there is no any difference between the process map and the flow chart. And this is, we discuss it in the define phase before we end. You remember we said there is a 4 zone in the within the Six Sigma. We have zone 1, which is a low hanging fruit or the ground fruit, and we have a zone 2, which is the low hanging fruit, and we have zone 3, which is the bulk fruit, and we have zone 4, which is a sweetness fruit. So this is some kind of the process flow or process map or flow chart we are using within the Six Sigma. But in the real life, many of you are using the process map or the process or the flow chart in your job, in your presentation, in your own process and procedure. We are using the process map. So it's the same. There is no any different. Process map and flow chart, they are giving the same meaning. Okay. Number four, we have something called Pareto analysis. So what we mean by the Pareto analysis? Pareto analysis is calculate the impact and strength of the cause according to the 80 or 20-80 principle of the Pareto. Who is the Pareto? Pareto is a Italian mathematician. His name is Louis Wilfred Pareto. So this guy, he came up with the principle of 20-80. So what is 20-80? He's saying 20% of the effort give us 80% of the result. And at the same time, 20% of the reason give us 80% of the problem. So if you have a problem and there is a main root cause for that problem, just you need to solve 20% of this problem, of these causes. Once you solve it, once you address it 20% of the root cause, definitely you will get the why has been solved, because the why is represent the other 80% don't care about. This is according to the Pareto analysis. There is a many, you have many root cause. So this root cause you will make analyze by using Pareto analysis. So Pareto analysis, he will tell you 80% of the root cause will give you the 80% of the problem. So the 20% of the root cause, when you address it, when you fix it, that means immediately your why will be solved and will be fixed, and then you will solve your problem. So this is according to Pareto analysis. So Pareto analysis, it's analyzing the competency factor for the specific activities, and the purpose for that one is to improve the result. So this is Pareto analysis. So let us take it in the Excel. This is a Pareto analysis, but first we need to develop this Pareto analysis by 4 steps. So just let us go for that one. We have this reason or effect or defect. We have these 7 reasons, and we have like frequency, which mean frequency means the repeating of the problem. It is happening 90 times. We are making a survey, or we are questioning the customer, or we are gathering the complaint from the customer regarding this 7 problem. You remember the parameters we have. This is the parameters of evaluating our for example service, what we call customer service. So we have a customer service, so we need to evaluate the customer service within these 7 parameters. So correct closing for the call, it is happening 90%, 90 times. So 90 times, it is not good closing for the for the call from the customer. Correct follow-up, we have how many defects? We have 80 defect, or means has been reaccuracy 80 times. Call opening 60 times. Complete documentation 16. Proper resolution for 15. Proper getting 5. Spelling mistake in documentation 4. So first thing we need to arrange from the big number to the small number, same like here, okay? And then we need to take the sum for all the frequency. So the total of the frequency here is 270. Now, step number 3, we have to calculate or to add one column. We call it the cumulative. So the cumulative, what means cumulative? Cumulative, and how we will calculate? We will put the frequency. The first cell we will put is the same. The first cell equal to the first cell. The second cell, the next one, which is this one, okay, plus the above one, plus this one. So this cell equal 80 plus 90, okay? This cell equal 60 plus 170. This cell equal 16 plus 230. This one equal 15 plus 246. This one equal 5 plus 261. This one equal 4 plus 266. So this is how we are calculating the cumulative number. So we need this cumulative in order to use the Pareto analysis to give us which is the main root cause is making this problem, or we need to get only the 20 out of 100. So the only 20, it will be our main root cause. So let's come here. After we add the cumulative, we need to add the percentage. So percentage equal the cumulative, okay, divided by the total of the frequency, which is mean, equal the cumulative 90, okay, divided by 270, which is the total of the frequency, equal. So this is the percentage. This is 33%, and so on. If we need to calculate this one also, cell number 2 equal 170 divided by 270, which is a total frequency, will give us this percentage. So and so on. So here we calculate the percentage, and we have already the cumulative, and we have the frequency. So the cumulative, after this one, we will not be used. We will use only the percentage. So here we need the frequency and we need the percentage. We will put them in Pareto analysis. We will select this one plus the percentage, go to insert. We will find the Pareto here. Where is the Pareto? Pareto, maybe here. Yeah, here is the Pareto analysis. So this one is this one, but I don't want to waste your time for designing, because you need to design some shape, you need to design, add, remove something here until you reach this this shape. But it's very easy. Most of you he knows how to do it, so no need to waste our time. If you don't know, tell me, I will make small video to how to get it like this. So what is tell us here? Here Pareto, he will tell you the 20% of the issue that you have, it is, which is 30%, 33%, 36%, and 85%, which is this 3. So this 3 actually is making your this is a 20 out of 80. So now it will tell you this is a root cause for your problem. What you need to do is just fix this 3 thing and your problem will be solved. So this is the Pareto, and this is the 20-80 principle. Don't bother yourself about the 80% of the causes that you have. Use the Pareto analysis. Pareto analysis, it will give you 80% out of the total of the causes. This 80%, when you fix it, you will get your problem done. So this is the main deliverable from the concept from Pareto analysis. Pareto analysis is about 80 to 20. So 80%, 20, 80, 20% of the root cause of the reason give you 80% of the problem. So whenever you found and you eliminate this 80%, your problem will be solved and your why will be done. This is the Pareto analysis. Number 5, we have
Badr,
yes, tell me.
yeah, can you go to the chart, the Excel
Yeah, Excel.
once?
Yeah.
Yeah, for the Pareto chart. In this one, the right side, the percentage which is next to cumulative. How did the percentage come? Can you explain that? I couldn't get it.
This
Yeah,
percentage.
yeah.
Okay. Let me insert one here. According to this law, percentage equal the cumulative divided by the sum of the frequency, or the total of the frequency. This is the frequency, correct?
Mm-hmm.
This is the total of the frequency. If you want to calculate the percentage equal, this is a cumulative number, okay? This one divided by the total of the frequency, which is 270. Okay.
Mm.
Enter.
Okay. All right.
Okay.
Yeah.
You drag down, it will give you the same, but you need to lock the cell.
Yeah.
Yeah, it will not come unless you lock the cell. If we lock the cell.
And this example which you give as reasons for defect, errors, correct closing, correct follow-up, what is it depending on? Call opening, complete documentation, the reasons for defects.
Again?
The reasons for the defects which you have mentioned here, it depends on what?
It depends on Pareto analysis. When you select the total of this table, okay? Cumulative here we don't need. We don't need the cumulative here. We came up with the cumulative only to give us the
get the percentage.
Okay. So the cumulative we will not use. Select the reasons and the frequency. Okay. Hold control. Select the percentage.
Yeah, that is
okay. Insert. Go to recommended. There is the Pareto here. Okay.
Yeah.
Which is this 3? What is this 3? This 3 is the first 3 you have it here, which is here because I add the label, some label here, it will give you the 33%. Where is the 33%? This is the one. Correct? 33%. Yeah. Okay. Where is 63%? This is the 63%. This is the one. Okay. Where is the 85%? This is the 85%. So what that means? That means these 3 reasons they are making the problem. Okay. So no need to bother yourself about this. Maybe it will be more.
20% of the
16,
defects.
Whatever. Yes. What you need to do is focus on these 3 reasons, eliminate these 3 reasons, solve these 3 reasons, and then you will get your problem solved. What is, if you find this is represent 20% only from the total reason that you have. Maybe here you have 16, 15, 100. In the big size, you have thousands. So in order to fix all these reasons, you need 2 years. So what Pareto he is telling you? He is telling you 20% of the reasons or the defect, it will give you 80% of the problem. So now you have this 20%. You have these 3 reasons. These 3 reasons, it's about or representing 80% of the total of the problem. So once you solve the 80% of the problem by addressing only this 20, then you will get your problem solved. Okay, clear?
Yeah.
Okay.
Thank you.
Welcome. Here we have number 5 or number 6, number 5. Sorry, we have the check sheet. Check sheet is very easy. Check sheet, we call it tally sheet. We call it also checklist or audit sheet or evaluation sheet. What is this sheet? This is, we use it if you are working out of the office. You are working in the field, for example. If you are working in the project for Aramco, for example, where you will go? You will go to the rig. Where? In the middle of the desert. So sometimes you will not able to have like a tablet, you have a laptop, you have even smartphones. You don't have it. So what you will do in this case, how you will analyze, how will you put your paper, your notes? You will use the tally sheet or the check sheet or whatever the name you will put it, audit sheet or whatever. So this check from document used to collect data, okay, in real time and at the location where there is a data is generated. So where you are collecting your data, yes, QC, okay. When you are collecting your data, so you will use the check sheet to help you to collect the data, and even you can analyze within the same times. So you don't have resources, you can use the check sheet or the tally sheet. The check sheet sometimes called tally sheet, evaluation sheet, and audit sheet. The check sheet also one of the 7 basic tools of quality. This is only what we have about the check sheet. We use it out of the office in the location when you don't have any kind of any smartphone, tablet, or whatever laptop. So then you will use the check sheet in order to put your data, to put your memories, whatever the observation you have in the location, you can use the check sheet to help you in that one. So number 7, which is no 6, sorry, 6, we have the histogram. Histogram, many of us are using the histogram, but some of us know the name, or some of us doesn't know the name. So the histogram will give you also root cause for some kind of a problem that you have. So basically, what again? Come up, Nawaz. What means by chart?
Normally, we are calling this one bar chart.
Bar chart. Okay.
Yes.
Yeah, this is another name. Okay. So this is a histogram. Histogram is a graphical representation of the data. So it is easy to understand and provide easiest way to evaluate the distribution of the data and divided the data in different business, or we call it class, level, or the range. And this is the shape of the histogram, and many of us using the histogram from the Excel. So this is the histogram. So let us take the same example we took it last for the Pareto. We will use it here also. We have this axis, and we have this frequency or the evaluation that we come up with regarding the degrees of this axis. So how we will use it and how we will read it and how we will get the root cause from the histogram. How to get the histogram or how to come up with this chart? Yes, you need to highlight, insert, histogram. Okay, insert it, and then no, this number, ticket access number, yes, number here. Put how many we have? About 16 axes. We will put 16. Enter. Then this is a histogram. So the same shape here, it is here. So let us delete this one. So here, I will tell you. This is a histogram. When you see it, you will remember that lecture number 1, we said Six Sigma is about a visual analyzing tools. We saw that in the fishbone diagram. When you look direct to the fishbone diagram, you can realize where is the root cause for that particular problem. You will say in the mother nature, where is the material, or in the machine, or whatever. Histogram also, if you find here which is the longest one, it will tell you where is your problem exactly exists. Where is the main root cause you need to focus on, you need to solve it, and then you will get your problem solved. So don't bother yourself about fixing all the root cause that you have. You remember when we said there is the analysis for the root cause. What means analysis for the root cause? You have the main root cause, and this is root cause. You can split it or you can break it down to small root causes. So that one, it gives us, you remember in the last lecture, we spoke about the process flow. Just we mentioned it in this 5 minutes before we talk about the process, which is zone 1, ground fruit, low hanging fruit, and so on. So here it will tell you there is a small part of the root cause. Yes, you need to fix it. Take it with you. Don't keep it because it will come bigger. So a small root cause, you need to fix it until you fix the big root cause or the main root cause. Here it will tell you your root cause, your main root cause is between 20 point something and between 26.25. So this is a degree. This is a degree for your main problem. So where is the 20 between 20 and 26? Where is between 20 and 26? This is between 20. Okay, and this is 26. This is the one. So what you need is just fix this one. Just fix this for a reason. Forget about other. This is the main root cause for your problem. Fix this root cause and you will get your problem has been solved. So this is one of the ways we use it in order to identify the root cause of the problem. We have 7 tools. We discussed the fishbone diagram, scatter plot, flow chart, Pareto analysis, and check sheet, and histogram, and the last one, the control chart. Control chart, this is very, very important. Okay, control chart, we will discuss it here, but we will discuss it more on the when we come to the control phase. So in the control phase, we will use the control chart in order to control whatever you've done in your project. You have to assure this companies, they will not go back to the start point. So you will use it. We'll use control chart, one of many types of control chart. We will know it in details in the control phases, but today we will discuss only general idea about the control chart. So you remember the mean. We said the mean total value divided by number of the value, or the average. You can use the Excel sheet in the average, it will give you the mean. Also, we spoke about the standard deviation. We said this from Excel STD. If you are working on the total population of the data, you will use STDB. If you are working on the sample or you take sampling from the data, then you will use STDVS. So P for population, S for only sampling. So let us see in the Excel, and let us have this example. So this example in front of us, this is about the number of temperature we have for one fridge out of many fridge in our warehouse. Okay, we are food industry. Okay, we have many fridge in our warehouses. We have many, so we took one as a sample. So this sample, we will calculate the temperature degree within 1 month. So for the whole month, we will write the temperature that we have for each particular day. Okay, guys. So what we need from here, we need to calculate the mean for this temperature, and we have something called UCL. UCL means the upper control limit. What means upper control limit? You have the mini and you have the maximum, and you need to keep your data within these two lines. Okay, this is a general meaning. In the control phase or in the control chart, we have something you call UCL and LCL. UCL is representing the upper control limit, and the UCL is representing the lower control limit. So your data, it has to be within these two lines, between the UCL and between the LCL. How we'll calculate the mean, how we'll calculate the UCL, and how we will calculate the LCL if we have only the temperature for the whole of the month. Okay, so this is the days, and this is the temperature, and need to calculate the mean. So what the mean equal? Mean equals the average. So if we want to calculate the mean for all these degrees, just we need to equal average. We will calculate the average for the total data what we have here. Sorry, enter here because it is round, but even we need these decimal numbers. So here it will be the 15 point something here, because I put round. So if I add, it will give you the same number, but here is a round. So this is the average. We calculate the average here. What else we need to calculate? We need to calculate the standard deviation for the same record what we took from this fridge. So this fridge is one of many fridge we have in the warehouse. That means this is representing the population. So here it's about sampling. We are not working on the population. We are not getting the temperature for the whole fridge we have in our warehouse. Only we took one, so we took a sample. So in order to calculate the standard deviation, we will use the P. Okay, guys. For example, equal STDV. We will use STDVS, which is the sampling for the whole of the data we have here. So this is the standard deviation we have. Okay, how we will calculate the UCL and LCL? UCL equal the mean, which we should have it here, plus 3 times standard deviation. So here if you ask ourselves why we get the mean and why we get the standard deviation, in order to get the UCL and the LCL. If you don't calculate the mean and standard deviation, you will not be able to calculate and get the UCL and the LCL. So the UCL here equal mean plus, let us calculate it here, equal mean, which is this one, okay, plus 2 brackets 3 times standard deviation, this one, close, enter. So this is the number, we have it here. So this is the same number, we have it here. So this is the UCL. So what about the LCL? LCL, just you need to, instead of plus, you will put minus. It will be minus. So we have the same number here, it's here. Okay guys, up to now is clear? If someone not clear for him, just raise your hand.
Clear.
So why we are calculating the mean? Why we are calculating the standard deviation? This is only we need because we need to calculate the UCL, which is the upper control limit, UCL or LCL, which is the lower control limit. Why we need the UCL and why we need the LCL? In order to keep our data within the range. For example, you remember we strike an example of the heart rate. If your heart rate up and down, suddenly goes up, which is a special cause variation, that means this patient is having a difficulty, so you need to call the doctor right now. So this is, we are using the same, I think the same concept or the same device in the ICU. They are using the control chart in order to keep their patient in the same or in the safe side, or to monitor the heartbeat in the ICU. So here we will use the same. Okay guys, we will calculate the mean and we will calculate the UCL and we will calculate the LCL. So in order to insert this shape, you need just to select this 3 or 4 tables. You need the measure or the temperature, we need the mean, we need the UCL, and we need the LCL. You will go to insert, recommended, you have it here. This is the control chart. Okay guys, so this is the same. This one is the same as this one. Okay. So here, you remember guys, special cause variation and common cause variation. You remember that one. If I ask question, this data now between the UCL and between the LCL, this is what we call it, special cause or common cause variation. Come on guys, I need to hear your voice. This is special cause or common cause? Okay guys, come in the chat. Yes, common cause.
Again, Badr, your questions.
Yes. Yes, Majid?
Your question again, please. I didn't hear you very well. Huh?
Okay, my question here. From this control chart, we have our data here, okay, within the UCL and in between the LCL, which is between the upper control limit and lower control limit. And this is the data flow. This data is common cause variation or special cause variation. We know what means special cause and what means common cause. Common cause when your data expected and normal to happen and you cannot even eliminate it and you cannot even identify. Special cause variation is not usually coming. There is an effect and it is easy to identify and even it is easy to eliminate. So this chart, it tells us which is the type of cause we have, common cause or special cause. Okay, guys, good. This is the common cause variation. If in this, for example, date 5, instead of 18, it is coming 20. This is a degree. Okay, up to now we are normal. But if it is coming 30, what is this one?
Special cause.
Yes, now we have a special cause. This is, and by the way, control chart in the manufacturing industry, or in the in some industries, they are putting control chart for the machines in the big screen. Okay, so they can observe direct the situation of the machine. So if anything happened to the machine, temperature or short in the electricity, immediately the readness, or immediately the data, it will go, or it will go up to the UCL or down to the UCL. So in that time, they will have indicators there is something happening for this machine, and they will move immediately in order to get it back to the same situation, which is you have to put it in the safe side, which is your data. It has to be between the UCL and the LCL. For example, you have your control team. Okay, your control team, they are sitting in the control room, and they are looking to the data, to the same data increasing. Okay, check this one. This is the normal. Up to now we are normal. Okay, but the day 1 or the day 2, the day 6, it's like this. Now we are in the safe side. Okay, but this is indicator that means your control team has to do something. You need to go to the fridge and check the fridge. Maybe there is disconnected from the electricity, or something, or the door is opening, so the temperature inside is giving high rate or high number. So you need to do something. But unfortunately, your control team did nothing, and the temperature goes up to the UCL. So in this case, what is the manager will do? The manager, he will ask for the record for the last week. Give me the record for the same fridge for last 7 days. What he need exactly? He need to observe the data from the day 1st when it was normal, okay, and then little bit increase, and then up to we reach this point. So he definitely will ask his team, his control team, where are you when you see this temperature is going up? Why you didn't take any decision? Why you did not address this issue? Why you did not address this special cause of variation? So if you move on and you eliminate this root cause, or you eliminate this special cause, we will not reach to this point. For example, suppose there is a food or milk, whatever, for mara'i, for whatever. There is a food inside this fridge, and this food is equal to, for example, 200,000 riyal, for example. So now what will happen? We will lose it. We will lose this amount of money. Why? Because your control team, they are sleeping. They are observing the data. They are observing the temperature is going up, but they did nothing. So this will give you indicator. Where is your problem? In the manpower, or your problem in the machine itself, or your problem in the services, technician, or whatever. So regarding this issue. So one of the effective way of using the control chart, it will give you indicator about the data that you have within your organization. It will give you the direct root cause for the problem. So once you eliminate this root cause and the data goes back, so you will be in the safe side. You will have full control of your data, since your data between the UCL and the LCL. So this is a control chart, and this is the last one of the tool of the quality. So only remain for us multi-voting. You remember, guys, we said in the analyze we have the door approach. Remember door approach, and we have the data approach. So data door approach when you don't have any kind of data. So we'll use the brainstorming. Okay. Process approach, you have the data, and then you will go for the 7 tools of quality and root cause analysis. And root cause analysis we spoke about during our explanation of the 7 tools of quality. And we have something called the multi-voting, which is we are going to speak about now. So what is the multi-voting? Multi-voting, when you, for example, go from brainstorming, or when you have, for example, we took just now the Pareto analysis and the histogram and control chart. They give us, for example, there is a 7 root cause you have to eliminate, 7 X's you have to eliminate in order to fix your problem, which is mean you have list of choice. Okay, you need to narrow this list of choice. Instead of 10, we need to make it 2. Okay, you have 10 choice, you need to make it 2. In Six Sigma will tell you the best thing to use it, use the multi-voting. So what is the multi-voting? Multi-voting is it is a way for group to narrow down the list of choices to manageable the few of these choices. You have 10 choice. When you reduce it, or when you narrow it down to 2 or 3, so this is when it will be manageable for you. So you will have the ability to manage this 2 or 3 instead of managing 10 root cause. So this is, it will give you also a good way of finding the main root cause for the problem. Once you have 10 root cause, 7 root cause, so you will use multi-voting in order to make it short, to make it less, or to make it very narrow. So there is some techniques for the multi-voting. So the techniques is will tell you the multi-voting, which is n. N means the voting. Okay, the voting will be n divided by 3. It will give you the number of the vote. For example, your team member, here in this example, your team member is 12. Okay, 12 means the n. N means the number of the teammates, or the number of your team members. Okay, that they will be vote. N equal the number of the teammates or the team members. Okay, in the multi-voting, we will tell you this number of the team you have 12. You have 12. You will multiply it by 3, equal 4. So what is the 4? 4 means each one of your team, he is having 4 chance to vote. For example, vote card, put it in the box, you have 4. For example, we have 10 causes or 10 X's. We have number 1, 2, 3, 4, 5, whatever, blah, 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 until 10. Okay, we have Bali, Majid, for example, Ahmed and Said. Each of one of these guys, he is having 4 choice or 4 voting card. Voting card regarding what? Regarding this 10 problem. So he will say problem number 1. I think problem number 1 is X number 1 is the main root cause for this problem. So which one you will vote? You have 4 votes. He will say, okay, I will vote 3 of my votes, 3 of my card, I will give it to number 1. And 1 of my vote, it will goes to the X number 2. So his 4 has been finished. Then we will goes to Bali. Bali, he said, no, I agree with Majid. The X1 is the main root cause, but I will give it 2. Only 2 from my vote card. But I will give number 4 also 2. This is my own assumption. Number 4 also 2. Maybe it will be the main root cause, and so on. Then Said, he will come. He is having only also 4. Said, he will say, I agree with Majid. I will give 3 to this number 1 or to the X number 1. I will give 1 to the X number 3. I think X number 3 is also can be main root cause for this problem. Then in the end of the day, we will calculate how many X's got vote card. So from this one, we will realize the X number 1, it goes 3, 2, 3, so which is the 8 card. So the total of the card has been given to this X number 1. What that means? Means number 1, the root cause number 1 is the main root cause for your problem. So you need to solve the root cause number 1 and then get your problem has been solved. This is, we call it multi-voting. Multi-voting, multi-voting is coming, or can use it from the X's, or the root cause that is coming from the brainstorming. Okay. Also, when you have a list and must be narrowed down in order to choose 1 or 2 root cause. Also, the decision must be made by group of judgment. It's not taken by only 1 person or 1 team member. The judgment or the main root cause has been to identify according to the group judgment, or will take which is the main root cause getting more vote card. Then we will give it to that that root cause will be your main root cause. And then what you need to do is address this root cause, eliminate this root cause, and in the end of the day, your Y definitely will be solved. So this is the analysis. This is what we have for today. We finished the analysis. So we spoke about if we have data, which is a process approach, we will go for brainstorming. No, actually, once we don't have a data, we will go for process door approach, which is we will use the brainstorming. And we have many types of brainstorming. We have the normal brainstorming, and we have the reverse brainstorming. The brainstorming itself, there is 3 methods. We saw there is a free will, and there is a round robin, and there is a card method. In the other side, the data process approach or data door approach, we have 7 tools of quality. We spoke about the 7 tools of quality, which is the root, the cause and effect diagram, Pareto analysis, the check sheet, scatter plot, histogram, and the control chart. And also we have the multi-voting, and the root cause we spoke about within the explanation of all the 7 root of the 7 tools of Colab. So this is what we have for today. If we have any question, so please go ahead.
Thank you.
No questions. Thank you so much, madam.
Welcome, guys. You are welcome.
Okay, thank you.
Okay. See you tomorrow.
See you.
Thank you, brother. Thank you.
Assalamu alaikum.
Walaikum salam.